Git internals. How Git stores data. What are Git internals? Git internals equals how Git stores your files and history behind the scenes. Instead of saving file changes line by line, Git saves snapshots of your project over time. Why? Makes Git fast. Keeps full history. Prevents data loss. Where Git stores data. Git stores everything inside a hidden folder. .git. This folder contains objects, references, branches, tags, head pointer, config files, logs. Why? .git equals the brain of Git. Deleting it removes version history. Git object model. Git stores data as objects. Main object types: blob, tree, commit, tag. Why? Everything in Git is an object. Objects are stored permanently. Blob object. File data. Blob equals stores file content only. It does not store file name, folder structure. It only stores actual file data. Why? Same file content is stored once. Saves space. Tree object. Folder structure. Tree equals represents a directory. Folder. It stores file names, folder names, references to blobs, references to other trees. Why? Builds the project structure. Connects files into folders. Commit object. Commit equals snapshot of your project. It stores reference to tree, author, message, date, parent commit. Why? Connect snapshots into history. Allows undo and rollback. How commits are linked. Each commit points to its parent commit. Structure. C1 left pointing arrow, C2 left pointing arrow, C3 left pointing arrow, C4. Why? Forms a chain of history. Makes time travel possible. What is head? Head equals pointer to the current branch or commit. It tells Git where you are, which commit is active. Why? Controls what you see. Moves when you commit. How branches work internally. Branch equals just a pointer to a commit. It is not a copy of files. Example. Main means commit C4. Feature means commit C3. Why? Branches are lightweight. Switching branches is fast. How Git saves history. Snapshot model. Git saves full snapshot of files, not differences, diffs, but internally. It reuses unchanged blobs. Why? Fast, memory efficient, reliable. How Git avoids duplicate data. If two files have same content, Git stores only one blob. Both point to the same object. Why? Saves disk space. Prevents duplication. Hashing. SHA-1, SHA-256. Each object has a unique hash ID. Example. E3B0C44298 FC1C149 AFBF4C 8996 Facebook 924. Why? Guarantees data integrity. If file changes means hash changes. Prevents corruption. What is the index? Staging area. Index equals staging area. It stores what will go into next commit. Flow. Working directory means index means commit. Why? Lets you choose what to save. Allows partial commits. Pack files. Compression. Git compresses objects into pack files. Why? Saves space. Makes transfers faster. Optimizes storage. Garbage collection. Git removes unused objects using gitgc. Why? Cleans old data. Keeps repo small. Improves performance. Why understanding Git internals matters. Helps you debug weird problems. Understand conflicts. Recover lost commits. Use advanced Git features. Trust gets reliability. Why? You move from user to expert. No more magic box feeling. Common beginner misunderstandings. Thinking Git stores diffs only. Thinking branches copy files. Deleting .git folder. Confusing commit with file. Not understanding head. Why? Leads to data loss. Causes confusion. Real life example. Git internals equals photo album system. Blobs equals photos. Trees equals albums. Commits equals saved album versions. Branches equals bookmarks. Head equals current page. Why? Git stores versions. You can go back anytime. In simple words, Git stores files as blobs, folders as trees, history as commits, pointers as branches, position as head. Git does not save changes. Git saves snapshots. Git internals equals how Git remembers everything. Git equals time machine for your code hourglass package.